Morning, everyone. I'm pleased to come to this school in African Space Leadership Institute meeting to be held in 21st September 2023. This invitation was sent to ClimSA program to present the overview of the program under African Space Leadership Institute program. And we thank for the organizer inviting us to share with you this small knowledge about the ClimSA and how it links with your program. As I already sent my biography, I will not really go back again. I think the organizer will let you know who are we. My name is Dieudonné Sadji-Safaka. I'm the team leader of ClimSA program based at the OECPS Secretariat in Brussels. What I'm going to present today is just to give you the overview of the program ClimSA, which is a program funded under EU OECPS partnership under the 11th EDF, European Development Fund, to support the activity in 3 regions: Africa, Caribbean, and Pacific. And we welcome you to this new venture of climate services and a related application for socio-economic development. This is showing us the space technology for policy development and climate resilience. I'm going to talk today to give you the overview. My purpose is not really to train those who are becoming the climate expert, but I'm giving insight what the program Intra-SAP Climate Service and Related Application is about. From this outline, you will see the introduction, the ClimSA objective, and also result area, the beneficiaries and the partners, management model, and a small conclusion. So ClimSA is a program, as I said, under the partnership between EU and the Organization of African, Caribbean, and Pacific States, with the campus 79 member states having 40 categorized as least developed countries, 15 landlocked developing countries, and 37 small island developing states. The OECPS is continuing facing challenges to achieve the 2023 SDG goal and the Paris Agreement. Why? By making effort to achieve development goal over the last 3 decades, however, climate-related hazard and the climate change impact have set back progress up to 20 years. Climate-related hazard is a threatening of our economy, and that is coming from the space science to see how to deal with the climate-related hazard. You will understand that more than 10 million people are affected annually by the disaster. OECPS is vulnerable to the impact of climate change. As the statistics show, more than 6% of people are small farmers who depend on rain-fed agriculture. And about 90% of all the disasters in Africa are weather and climate driven. Despite only African countries, Caribbean and the Pacific have contributed only with 4% on the global greenhouse gas emissions, African, Caribbean, and the Pacific state is the most vulnerable region to the adverse impact of climate change. That is bringing the background of this program, intra-SAP climate services and the related application, because we see that climate-informed decision-making framework is a key to face the challenges of a climate change impacts. That way, the climate services and the related application program was designed to face the challenge the OSCPS country are facing. And I'm going to present the ClimSA program objective and the expected result. But before to go more further, let's start by the objective of ClimSA program is to strengthen the climate service value chain through building the capacity of decision makers at all levels to make effective use of climate information and the services. So the main objective to strengthen climate services value chain by building the capacity of decision makers at all levels to make an effective use of climate information and the services. And the goal is to contribute to strengthen production, availability, delivery, and application of science-based climate prediction and services. You will understand better as we proceed with this presentation. Let us start by defining climate science, where the climate services is developed from. Climate science, or the climate dealing with the envelope of the Earth, what we call atmosphere. The atmosphere is the gaseous envelope surrounding the globe of the Earth. And this atmosphere, which is really the envelope, is also the living place of all the living either the human being, the vegetal realm, the animal realm. We all are living in this atmosphere, and you will understand why the space science is very important. Without the space science, life on the Earth planet becomes very difficult. If our Earth is habitable, life can sustain on Earth because of the Earth atmosphere. And that atmosphere is well organized by many layers, with the first layers, troposphere, and the tropopause is the boundary. The second layer is called stratosphere, and in the stratosphere with the ozone layer, with the next one, the mesosphere and the ionosphere. Those layers is well organized to keep life possible on Earth. Without the atmosphere, life is impossible on Earth. As you know, the atmosphere is composed with many gases. Among them, the principal, the key one, is the nitrogen, oxygen, and the trace gases. And the oxygen is the main gas for our respiration or for our life and the photosynthesis process. if you consider the layer of atmosphere by comparing with the profile of the temperature, you will understand that in the troposphere, the temperature decreases as we go up in the high. When you go up, the temperature decreases until to reach that layer we call the troposphere, the tropopause, which is a constant layer where the temperature remains constant. After that small layer of the boundary between the tropopause and the second layer, the stratosphere, where we can observe that the temperature in the second layer start to increase as we go up with the high, until we reach the next layer, what we call the stratopause, where the temperature remain constant and start again to decrease, as you can see on your screen. This is the layers, how it is organized in the atmosphere. And climate science is dealing to understand the functioning of the atmosphere and the interaction between this envelope and the being living in that space. So in the atmosphere, the first layer, what we call the troposphere, is the layer where we have all the meteorological phenomena. We can observe the winds, we can observe the clouds. In this first layer of the troposphere, that is the layer in touch, in connection with the Earth surface, where the life of the human being, animal, vegetable, and other end are possible. When we talk the space, the atmosphere is the first layer we know about the space. Of course, after the Earth atmosphere, there is also the extra atmosphere, but that don't really be our focus for those who are dealing with meteorology. We are concentrating on studying the Earth atmosphere, which is the envelope surrounding the Earth. How do we observe the parameters in the atmosphere? We use a satellite. We use the ground station. We use the ship on the ocean, and all those sensors in the atmosphere are transmitting data through the antenna, which now will transfer those data to the National Meteorological Department for storage, processing, and generating information we would help people to make use of for development. So meteorology is a part of the space science, which is dealing with a climate issue. What about climate? Sometimes people make confusion between climate and weather. What is the difference? We talk about weather is the status of the atmosphere at the time, at the short term, observing status of the atmosphere at the short term range define the weather. What will happen? What is the status of the atmosphere today, tomorrow, maybe up to 5 days? That defined the weather condition. But now we talk about the climate system when it becomes the average state of the atmosphere in long-term range. Weather conditions are the state of the atmosphere for the short term, and the climate conditions are the long-term average of the state of the atmosphere. If they give you the information, the weather information, that is the current condition of the atmosphere, the state of the atmosphere, and the current condition, and the short-term range. When they give you the climate information, that is showing you the long-term average of the status of the atmosphere. But as I said, I'm not giving this lecture to those who are the maths expert, but those tomorrow will become the space experts in terms of building governance, law regulation. They need at least to know the basics of the atmosphere science. And in this screen, you are seeing the global observing system. As I said, we use satellite, we use the ship, we use the ground station to capture the status of the atmosphere through the parameters which define the variable of the atmosphere. And on the ground, we have the upper air station, we have the surface station, we have also the weather radar can also capture the status of the clouds. And we have also the plane, the aircraft by flying, they've got also the sensor, can also transmit the status of the atmosphere as they are moving, they're flying. All those data will help us to transform those atmosphere status to the information helping people to take the right decision. Let me now start to enter in the business. Climate services value chain. As I said, intra-SAP climate services and the related application, ClimSA, is a program dealing with the climate services. So it is better for us to understand what does it mean by climate services. And we are going to start to learn about climate services value chain. For the first step, climate services provide climate information to help individuals and organizations make a climate smart decision. Because the atmosphere is the envelope surrounding the life of people, of vegetal, rain, animal, and others. Life is possible because of the atmosphere. And to sustain life on Earth, people need to understand the status of the atmosphere. And since we are in the chaotic nature, the weather change as much as possible. Climate is unstable. It can change by few minutes, by few hours, by few days, by few months, by few years. As the scale become long, we talk about the climate. As the scale become very short, we talk about the weather. So the climate information derived from the measurement of the parameters or variable defining the atmosphere can help us on how to plan to fight against meningitis or to organize vaccination in our region linked to health issue. Malaria issue is linked to weather condition. The how to plan for the public health prevention, you need climate information. Do I need to plan to plant drought-resistant seed next season? You need climate information for agriculture side. How much solar energy can we expect to get in this area? Today, we are in the transition to the renewable energy. Transition phase to maintain, to make our society resilient to the climate shock. We need to change, to move from the fuel to the renewable energy. And how to plan for renewable energy, you need climate information. Will we need to evacuate the city due to the forecasted heavy rain, the extreme event? The forecast is warning that we are going to observe the extreme event. Heavy rain will fall in this area. Those are dealing with disaster risk management need that kind of information to make the early warning and to take the action for them to preserve life. Or you can also need the climate information to start restricting the use of water. As you know, in the water cycle, everything starts by the rainfall. That is where we get water. Our river are fed by the water coming from the rainfall. How should I deal with the drought? You can imagine that all the socio-economic sector dealing for development are sensitive to climate situation. That's where the climate services value chain become very important for our development and our sustainability over this health, our planet. So now, let's talk how do climate services work. The climate value chain is defined by the all step the expert in climate science or weather professional will deal with before to generate the last information related needed to the socio-economic sectors. So the climate services value chain encompasses the first step, the observation network. You need to have sensors around the globe to observe the parameters, the variable of the atmosphere. That will give you information on weather, water, and the climate. After observing, collecting all those data through your sensors, you will transmit those data through the telecommunication system to the national center to produce data, information, and services. Of course, the main purpose, the main business of the climate science is to produce how to transform data to the information, knowledge, and the services. By measuring the temperature, if someone just tell you, today we are going to have 30 degrees, Celsius. It doesn't make sense. 30 degrees. And what? And what next? We need to transform that information according to the user requirement. For a human being, that temperature will define the comfort zone. Either if it's too hot, to take action how to cool down. If it's too cold, how to warm up. Cooling and warming an environment becoming already a service we are rendering to the users. So you need first to have data to produce that information. After producing the transforming data to the information, we need now the second step of the value chain, provision and application of climate services. How to apply that information to different sectors which are sensitive to climate information. If you apply your climate information to the sensitive sectors such as agriculture, water resource management, energy, disaster risk management, disaster risk reduction, those end users need to assess the usefulness of that information and to see which decision should they take to face the threat. After taking a decision against the situation around our atmosphere, around our climate or weather conditions, at the last stage, we need to monitor and evaluate the user outcome. What is the benefit by using climate information? How useful climate information were in my sector, in my specific area of interest? And to produce that information useful for the end users, you need to have data management system. You need to have processing system to transform those data to a product, such as a forecast or the statistical analysis can give you the meaning information can be used by any sectors. So those output we are getting from the data should inform the user decision and action. And here I can show some output in terms of the product and the services, whether any climate expert can produce. For example, in the case of weather, we can know the onset of the season. We can know the accumulated growing degree. We can know the day for the season. We can know the heat related to the livestock. We can know the fire danger. We can know how a disease outbreak can happen. And the climate variability, such as the crop yield forecasts, can be produced. The average date of the beginning and the ending of the rainy season can be also driven out. The average first and last frost date, crop weather calendar can be generated. Drought-induced warning can be also produced. Or we can have also or at the climate change scenario, the map of the change in agroecological zoning, we can know the map of change, the first and last frost day, and we can have also the status of the atmosphere for the next 10, 20, 30 years. You know, in infrastructure, when you build a dam, you have at least the time that dam can sustain on. And those kind of decision and planning, you need to have some projection for you to take a good decision. And the user decision and action, you can know how to plant and harvest, when to irrigate, for example, when to apply fertilizer and pesticide, which kind of method we like you to use for your crop. You can know how to invest if you are facing drought condition, how to invest more in efficient way for an irrigation system. So climate information is a very key information, key input for the economic growth in our system of development. And this passed through the climate services value chain from the observation, production, application, decision, and evaluation of the outcome. Let us come now to talk about the ClimSA result area. The program ClimSA, Climate Services and the Related Applications, have got 5 result area. The first one we call User Interface Platform. The second, the National and the Regional Climate Services Information System on how to generate climate information and climate services. The third result area is access to data and observation. The fourth result area is capacity building. And the last result area is policy awareness. I will go in detail to explain how do we incorporate all those result areas. So in terms of the implementation action plan, where we define the implementation of the program, in the first result area, we are dealing with stakeholder interaction and user interface. You need to have a platform where the users and the producers should meet together for them to co-design, to co-produce, to co-formulate on the climate services. Climate experts have got knowledge, and they would like to assist users to produce, to generate, to develop a relevant and tailored climate services. We need first to collect the user requirement. And in the user interface platform, we have 2 key points. The first one, user interface platform itself have 4 components. The first component is need assessment. They need to meet to hear the request from the users. Agriculture people will let you know what do they want in terms of crop production. Water resource management, they would like also to know how to design the infrastructure, how to manage water availability. And in the platform, they need to see how to apply those information. So users and producers need to sit together and advise on the weather, on the adversary how the end user must apply those information. And the user must now verify this information they use. How useful were those information to meet their requirement. And in the platform, they need also to assess the usefulness so that they can bring out the weakness, the strength of that product for the producer to amend, to improve the quality of product. That's where we have these two arrows in blue making the feedback mechanism. After the user have got the information and the services provided by the expert, they need to give back after the evaluation the feedback on the weakness, the strength of the product they did use. And those reports from how did they see the product were relevant or not, what was the weakness. Now the climate expert at the second cycle will try to incorporate those requirements to improve the range of the product and the quality, the specification of the product and the services. So in the first arrow in blue, the feedback mechanism is about identification of a product and the feedback. They get the information from the climate expert to generate. And from the climate expert, they've got also more or less 4 stages to generate the product and services at their side. The first one is the observation, where you gather all the information. The second one is the processing, how to deal with those information to produce, transforming data to information, processing. After processing, as you know that our atmosphere is a global envelope, weather doesn't have or doesn't follow the national barrier border. For the science purpose, you need to downscale your output model coming from the global scale to the regional scale to downscale to the national scale until to reach the ground scale. You can imagine like a small island in Lesotho. If you are using the satellite remote data, sometimes with the grid of the satellite image, that island or that country, that kingdom, so sorry, Lesotho is not an island, that kingdom, the small kingdom, which is within, surrounded by South Africa, will not be visible. By talking about island, I could refer to Madagascar, to Seychelles, Mauritius, Comoros, and so on. So the global product doesn't have the meaning for the small island or the small country. And they need to go through a process we call downscaling, where you incorporate the local condition to the global output to tailor those products to the local condition. After downscaling, now you can tailor products to the specific condition at the ground that will give you the information related to specific sectors, where we incorporate for designing, for example, the crop yield forecast. You will need some data on phenology, how crop grow up, different stage that the crop can go through. Those information will help you to make a good modeling on crop weather-based forecast. So from this tailored product, you are going to send to the second arrow to the users for them to apply. And it will go again, they will apply, they will verify, they will evaluate. Where they see the weakness, they will send the feedback, and this cycle will make a loop where every time a product and a service is produced through the co-design, co-production, it will improve. By improving, user will increase the usefulness and their productivity, and that will build our economy. So the first result area, stakeholder interaction and user interface, is to gather, to identify the need of the users, and then the expert to develop the product, bring back to the users to apply the product, to verify the product, to assess the product, and anything they will notice, they will observe, they will send back, and that cycle will continue to be improving. So the main key point here is meeting user requirements. So ClimSA is building this platform to let the users, agriculture, water management, disaster risk expert, renewable energy expert to sit together, and the weather and climate expert to design the new services to afford and to prepare them for their use and to build resilience in our economy. So ClimSA is promoting to set up this user interface platform with these two big systems or process. And the platform are based at the Regional Climate Center. You will see when I will arrive to describe the beneficiary of this program. What is the deliverable of the result area 1, user interface, stakeholder engagement? Today, experts are no longer responsible alone to produce a tailored product. Stakeholder must be engaged. They must contribute so that the product to be relevant and tailored to their needs. That will be the deliverable to measure if that result area was reached by involving stakeholder and coming out with their engagement, their participation through the process of co-design. The second result area in the implementation action plan is the regional and national climate services information system. Climate services information system is the setup of the infrastructure that is generating, processing climate data information to the services. And in the co-designed setup, we are here presenting a system with the feedback by showing again the climate services value chain from the observation, transmission of data, database storage, processing of the climate information and innovation, co-production and application, where the users are coming in to present their requirement through the user interface platform. Then we will get a tailored product through the boundary organization, communication brokers will get that information to communicate to the users and the users to the end users. And the end users will apply the information, they will assess the information, and they will send back the feedback through the user interface, who can improve, advise for the new product to be designed. Either they should go through the observation by making the new system to observe the new variable can inform and improve the new products. So in the result area 2, climate services information system, we like to make sure that all the beneficiaries, they have the minimum, the required infrastructure, equipment to generate, first of all, to observe, to process, and to generate climate information and services. As a deliverable in that result area, we would like to have an automated climate services information system where all the components of the climate service information system are interconnected, where the human being intervention becoming less and less, so that the system can get the data from the station, transmit data to the storage to the processing to the generation of the information and services. That way we like to improve African climate centers for them to generate the valuable, accurate information for user sectors. Here, I would like to present the climate service information ecosystem, which has 4 components. The first one, the input, which comes from the observation. And observation can be on the ground or in space. In space, we use satellite to probe the status of the atmosphere through the sensors and send that information to the center on ground through the antenna. The second component of the climate services information system is the processing, how to transform data to reliable information, tailored information. And the transformations are made through the higher performance computer, HPC. From transforming data to information, information to services, we have another system in that sector, under that component of transforming, processing, where you need also to monitor how the atmosphere are functioning this year, the next year. What was the status of the last 8 years? What will be the status of the next 20 years that become already projection as the product? So the second component on the climate service information system ecosystem is the processing, the cycle, as it is shown in this figure. The third component of the ecosystem is the deliverable tool and communication. After producing your information, you need to communicate to the end users. Mean of communication can be by telephone, it can be by website, you can send by fax, social media. So in the climate service information system, ecosystem, you need also to manage the communication means for your information to be reliable, accessible, and to be available to those in need. You can generate your information, but if that information doesn't reach the users, it will become useless. And the fourth component of the climate services information system is to identify the user community who will use your information. And that information is relevant for what sector? Is it information for agriculture, for health, for water, for disaster risk, or for energy, according to the pillar of the global framework on climate services? So if you need to really to construct, to set up a system to transform data to information and services, you need to have this ecosystem. The first one, the input, data coming from the observation, either on ground or in the space, the upper air. Those information, you need to communicate them or to transmit them to the processing center. And you will need the higher performing computer can run, transform, analyze those data to the information. If you have transformed data to the information according to the user requirement, you need to know the mean of communication. How you are going to reach, by which mean you are going to use to reach those end users. And the last component, you need to know the user community. Who is the beneficiary of the information you have generated? So this is defining the climate services information system or information ecosystem. It gives you at least how weather forecast, climate projection has been generated through this system. The third result area of ClimSA is access to climate observation. You can't produce climate information if you don't have the initial data. And the data comes from the observing the status of the atmosphere. That will help you to understand your environment and to get the interaction of the environment and life or the living in that environment. So in ClimSA program, our purpose is to interconnect the national center to the regional center and the regional center to the global producing center for data, information, knowledge, sharing or exchange through the global telecommunication system or the global observing system based on two ways and a triangular scheme. What are we saying from that? You receive data from ground at the national level. That data should be sent to the regional center. Sometimes protocols make it difficult for us to generate the reliable and tailored climate information if we don't have the ground data, the national data observed at your national level, at the community level. It is a bit difficult to generate a reliable information. As I said before, the atmosphere is the envelope without boundary. But to make sense what the global model are generating, we need to input data coming from the ground. That way, you are dealing with the space law. We need to have a kind of the space law of data sharing. If you don't share data, it is difficult to give you back the product information you require for your sector. How can we have the space law on data sharing to get back a tailored information for our sector? But you know the context of Africa, why sometimes National Department of Meteorology and the Climate Services are not sharing data, sometimes because they are under budgeted by the national government. And they expect by getting the cost recovery through the data they collected, they store and they transform, it can help them to have some income to run their business. If today there will be a new law by saying any grant, any financing system coming to the country must have a certain percent to support the climate system for observation, storage, processing, then the data will be available for everyone. The national met will no longer bother how to collect those small input for their functioning, for their management. So this is a case I would like to put on your table when you are dealing with the space law. As we have one envelope, one atmosphere, the atmosphere is not separated. It is one envelope, one world, one village. We need to have also some kind of arrangement can help those who are making observation on the ground can be supported so that they can avail data to the international community. That is the law you can generate to help to resolve that burden, that constraint of sharing data, especially for African countries. So far, there is not law to help member states to take advantage of the benefit of all the investment coming in the country. Sometimes you will see Met Department are the poor department if you compare in terms of the percentage of the budget allocated to their activity. Why? They are monitoring the atmosphere condition for the sustainability of the national development or the national program. And we are intending under ClimSA to improve the national observation system or network. We are trying also to connect the national automated messaging system to the regional climate center so that the national department can send through the automated way to the regional center data will help them to downscale the global product to the national tailored scale. Without the national data, it is difficult to downscale product relevant to a specific country. So we need also to connect the regional center to the global producing center. Those are dealing with the global model. The deliverable of the output tree under ClimSA is global take stock on climate services for adaptation status to be able to provide local information to the global system so that we can have climate services for adaptation. If we don't have that law, that regulation on data sharing, it will become difficult for us to adapt to have the relevant tailored climate information which can respond to our national user requirements. This is our ambition vision and the OACPS to interconnect all the 8 regional climate centers for data sharing and the product. Getting in touch with the Global Producing Center to send the data and the product to the RCC, and the RCC to send the information to the Global Center. This will help us to be updated on the latest development in the climate modeling science. And we are going to get the quality. We are going to see the quality of our product to be improved because we are linked to the Global Producing Center that will help really to improve our product. So this ambition is to interlink all the RCCs, Climate Regional Center, among African countries, regions, and Pacific and Caribbean for the case of OACPS Secretariat. All of them to be linked to the Global Producing Centers, according to WMO structure. To make that interconnection possible, you need to define data access plan, the access data plan. The access data plan is an inventory of all the means to access data and information. As you can see here, transmit is the transmission of meteorological information through WMO switching system by providing the quality control and the proactive diagnostic that will go through the database metadata, data monitoring, the composite message, data and system statistics, data processing, and so on. In the last layer, you will see the mean. You can transfer data through a scanner, through a printer, through a mail, through a WMO website, through the airplane system, the automatic weather station, the satellite, the global telecommunication system, and so on. So all the center need to access the infrastructure needs. How to access data? And what is the data, the access data plan? We need this investment, all the center to be connected to all the means of communication or data access. To do so, you need first of all to make the infrastructure assessment. What do you have? What do you need? What is the gap? And then we can see how to assist. The second step for access data plan is the interconnection requirement. How to connect a region to the global center. Define the requirement. And the third one is the implementation of the interconnection plan so that our RCCs are well connected to the worldwide advanced centers. The fourth result area of the implementation action plan is capacity building strategy and the training program. We need to build capacity in Africa, in Caribbean and Pacific. And ClimSA have designed this strategy with 4 pillars. The first one, in the middle, the strategic objective, have got 6 strategic objectives. The second pillar is the strategic mechanism, how to build that capacity, moving expertise globally to the end users at our local level. To make it possible, training must be categorized. must be specified according to the need and the level of expertise and competency you would like to build. We don't need anymore the general training which does not fit to any competency skill. We need a better learning environment, and we need partnership for co-creation and development of solutions. These two pillars are the key ones. They have been supported by the first one, which is the current status need assessment. You need to know the capacity today before you define the capacity building you would like to have. What is the current status in ACP in terms of the capacity need assessment we made? There is lack of capacity and equipment, dependency to the external expertise, weak sustainability and governance, and all most vulnerable. To build capacity, we've got 4 levels of delivery. The first delivery level, the global support. We at the Brussels office, we can organize some training for the regional centers. Regional training, and the regional focus is on training the trainer, training of trainer, so that the trainer will continue doing the work of the global level. So the global expertise are training the trainer at the regional level. For the regional level to take over for training the national level, at the national level to take over the training at the community level. That is the way we are thinking to build capacity, because it's not normal to get an expert, a consultant from overseas countries, from outside the region, coming straight away to train people at the community level. There will be constraint and a limitation. Sometimes the language of those communities will be a barrier. They were thinking. But if they are trained by the national expert who are already used to the community way of doing business, they can really overcome that barrier of culture. So to make effective our capacity building, we need to transfer the global expertise to the local level. By building capacity of trainer in the region for them to take over. All those training must have the cross-cutting principle in terms of gender balance, user-centered service development. Your service must be to meet the user requirement, investing in cost-effectiveness information system. Don't bring a very expensive, which people cannot maintain after the installation. Cost-effective infrastructure, and build local competency for decision support system. That is the vision we're expecting for Africa to have. The first year, you get expert consulting from outside. The second step, build your own capacity for them to take over at the national level, and the national level to go up to the rural people, to the community level. And all those efforts must come out by meeting user requirements. User requirement in terms of the climate services information system is to make the last product available, the product to be accurate, the product to be accessible, the product to be actionable. It must help the end user to take action, and the product must be accessible to assess the usefulness, how to assess the product or the information. that will build the climate resilient society and achieving the global development goal, the sustainable development goal. What is the deliverable of result area 4? Product generated by local people. In other way, local capacity has been built to generate tailored information. The 5th result area in the action plan is climate-informed decision-making is enhanced. Climate-informed decision-making. Mainstreaming climate information to policy, program, strategy, and project is one of the target of ClimSA. And our model of science policy interface is to start with university. Universities are building output, knowledge through the research. Those products, those tools are sent for operational use at the regional climate centers. The regional climate center are translating those products to meet user requirement by building the user interface platform to use the product and assess the effectiveness or the benefit of those products. By using the products and making the evaluation of the benefit, that can lead us to policy development. Sometimes the policymaker will not understand your product and the services, but when they can see the benefit through the evaluation of the benefit, it will be easy for them to develop policy. This is the model ClimSA would like to apply by starting by RCC, getting the operational product, make them relevant and tailored to the user need through the user interface platform, and helping them to evaluate the benefit, the socio-economic benefit, then coming out with the result through the awareness of the policymaker. What was the benefit of the climate information generated that will lead to the policy development? So the deliverable of the result area 5 on mainstreaming climate information to policy, strategy, and program, climate mainstream in national strategy, program, and policy regulation. We believe that this mechanism of transforming science to policy development is a key point underpinning our resilience to the climate shock, the climate change impact or threatening. Policy must come through the benefit of climate information to different sectors. But to get the profit, to get the benefit, we need to develop the operational products that should be based on a research, as we say, science-based climate services. At our level, we are getting what is already available on the market, trying to build a user interface and to assist evaluating the benefit so that they can inform the decision makers on policy development, strategy, and program. By mainstreaming climate information for development or for socio-economic benefit, mainstreaming climate information to policy, strategy, and program that is based on the climate information role they play on different sectors. Public awareness, weather conditions, can give the awareness to the public to avoid, to prevent, and to let them to take a good decision. This provides essential weather, water, and climate information for them. So they need to incorporate the climate information in their usual information, user decisions for their common life. Planning purpose need climate information for economic growth. Socio-economic benefit analysis just to boost the enhanced productivity for all sector growth. Climate information can help policy development, government, business, and community to manage disaster and climate risk and adapt to the climate change. Yes, well-being is related to the climate information. How to build your shelter, how to create a comfort zone, protect life and livelihoods. If climate is mainstream to all the sector, in the climate sensitive sector, that is already a foundation to build a climate resilient society. And you can see the benefit from the space observation, generating the services, making sense and supporting our economy, our society. Space science is critical for sustainability on our health. If we mainstream climate information to different sectors, then we can have policy awareness and development, such as tropical cyclone policy, extreme weather condition policy, fishery policy, electric utility policy, and so on, that will support our development. So climate information is very critical. We can't cope with climate change if we don't develop the relevant and the tailored climate information for sustainability. Here, I would like to present the status of climate services functional category. WMO have defined 5 functional climate services with 4 categories. Of course, it's a bit technical, but at least for you to know that there are different categories of climate services. The first category is the basic services, the essential, the second, the full and the advanced. It depends to the criteria how to define a service as a basic. When you just observe and you give to the users just the raw data, you are providing the basic services. Essential, when you try to transform that information, that data to the information. The full, when you meet user requirement. The advanced, when you make impact on the socio-economic benefit. What do we see here? And the first functional climate services, what we call the basic services, the more available services in Africa is the basic. 78, according to the survey in 2019. So the more relevant and available services in Africa, we have the basic services. 79. Following by essential 57, as you can see, as much we are moving to the advance, to more impactful services, to more effective services, the availability of those services are lacking. Meaning that we need to do effort to increase the quality of our services in Africa. On the governance, policy, regulation, at least WMO is providing guidelines, regulations for all the med sector and climate services to function according to the international standard. Up to 74 requirements are met. On the user interface, how do we create that platform where the users and the producers are coming together? First of all, to assess the need of the user, the producer to get those needs to incorporate in the product generation and to bring back the tailored information meeting their needs. We can see also that what has been done is only the basic services in the user interface. We need to make it advanced, responding to the valuable services, making difference and adding value to our economy. On the monitoring and evaluation of the quality of the product and the benefits, you can see how less the percentage of our product are. On the application, provision and application of climate services, at least African countries are applying climate information. They're using climate information and services. This category, this function are well done. As we can see, more than 50% the availability are combined for all the 4 categories of climate services. And the last one, capacity building, at least 60% of the capacity are built in Africa through our national services and the support of the regional climate center. This is the status showing that we still have effort in the basic services to bring it higher up to the level of advance. User interface to make effort to bring it more higher in terms of the percentage, the coverage percentage higher in the advance. And the weakness in the climate services in Africa is economic and socio-economic value. As you can see, it's very less according to the figure. One of the key problems could be also lack of governance, lack of law, space law in data sharing. If that can be resolved in your study, it can help to make value of our climate services to add value in socio-economic benefits. Let me give an example of a climate services products produced in Africa, especially in IGAD Climate Prediction and Application Center, called in short ICPACT, based in Nairobi. They produce the seasonal rain onset anomaly. The forecast onsets and cessation anomaly for June, July, and September 2020-19 rainfall season are computed as a deviation from long-term average. At the right side, you will see the map with the red and the green color, showing the delay onset and the early onset. This product, as a climate service, is useful for crop expert to know what crop to plant when the rainfall will be delayed or when the rainfall will be early than the season. It can help also the movement of livestock for better foraging conditions, when to use reservoir and to supply for crop. This information can help agricultural experts to take the right decision and increase productivity. Benefit for crop, livestock, and water supply for irrigation. As a result, high crop yield and a higher weight gain for livestock. One of the examples of the climate services product and its usefulness. Let me just rush before to conclude for today, the beneficiary and the partners under ClimSA. As I said, we are supporting the regional climate centers. In Africa, we've got six result areas with African Center for Meteorological Application for Development based in Niamey, in Niger. We have agriculture, hydrology and meteorology based in the same city in Niamey, in Niger. We have ICPAT based in Nairobi, Kenya. We've got SADC Climate Services Center based in Gaborone. We've got CAPC Central Africa based in Cameroon, Douala. And we've got Indian Ocean Network node who are about to be installed or to set up in Mauritius, the headquarters of Indian Ocean Commission. So ClimSA is supporting all the 6 regional climate centers in Africa to make sure the user interface platform, the climate service information system, data access, capacity building, and mainstreaming climate information to policy are well established in those regions, and also they're having at least one pilot country to showcases how to apply climate services, what we call the application of climate value change at the national level. As a partners of this program, we've got the OSCP Secretariat who are managing capacity building strategy. We've got the WMO, have got a big contribution as the authoritative institution. We've got the European Union Joint Research Center based in Italy, contributing in developing the climate services station, which is a tool to generate climate services. We've got European Organization on Meteorological Satellite, EUMETSAT, based in Germany, who are dealing with this, the meteorological satellites, and also having part in capacity building with the RCC in terms of the satellite-based data set. We've got African Union who are dealing with the Puma station and procuring other equipment for the RCC and member states. And we've got themselves, the Regional Climate Center, who are managing the program at the regional level. All those implementing partners, our goal for involving them is to bridge the capacity gap between the global expertise in climate service development and Africa Caribbean Climate Services Center experience by contextualizing and integrating local information to tailor climate services for ACP user requirements. So we are having the support of the European Union through the grant under the 11th EDF to support all the RCC to build their capacity and to serve the national and the community, building the resilience by producing the climate information to face the climate impact, the climate change impact for adaptation. Management of the program. The program is managed by the steering committee, who are meeting twice a year to analyze the progress made through the the logical framework. And we've got the theory of change under ClimSA, what we call the management model of ClimSA, which is represented by this graph. You will see in the cycle, at the outside in the blue cycle, we are starting our management of the program by building first the stakeholder engagement, putting all together, consulting, assessing the need of stakeholders. After getting the stakeholder engagement, we need to set up the user interface for co-design, co-formulation, co-production. After we've set the user interface, we are passing in the production of climate services. By generating the climate services, we are applying and uptaking by the users. After applying the climate services to different sectors, we can let users to evaluate the outcome. That can bring policy development. And to make it easy, we've got 4 underlined activities in the management of the program, starting by the need assessment. So need assessment will cover from user stakeholder engagement and the user interface, as the outcome is need assessment. If we have the need assessment, then we can develop the decision support tool. By developing the decision support tool, we can reduce the risk by applying those information to different sectors. If we reduce the risk, the threatening of climate change, then we can get the benefit and change the livelihood of our population. That will bring us in the process for those RCC to be certified as WMO designated center. That will create the climate resilient society and will lead to the sustainable development. The intermediary outcome, we need first to develop system, we need to develop strategy, we need to develop tools, and we need to make the policy awareness. That is our theory of change. From the inception up to the closure of the program, through all the steps. And this is defining our strategy for the management of the program. And we've got the second level of the management is the monitoring and evaluation M&E system to support the implementation and to make sure that the log frame is reached according to the targets. And here I'm presenting the monitoring and evaluation criteria for the training outcome to build capacity, because one of the key points, build capacity of the RCC. There are 4 levels of indicators to assess the training outcome. The first level, the learner feedback. We need to get the feedback from the learner. How was the training? In terms of the content, in terms of the learning process. The second level of indicators, learning output change on job performance. How the training did improve job performance of the staff, of the expert. The third level of indicators of the training outcome, learning impact on job performance. The impact of the job performance may be promotion. After people went through the training, the job performance was very good. It brought management to acknowledge that improvement by promoting those staff. And the last point to evaluate the training outcome is the learning outcome to the organization objective. For our case, we encourage RCC to be accredited as a WMO designated center. If a center which was in demonstration phase to become a designated center, it's already proved that the training people did receive made a change because the center has been upgraded to the designation. So those are the criteria people can use to see the effectiveness of the training output as a modality of the management. In conclusion for today, we are saying that ClimSA program is very important to improve the decision support system for policy development. ClimSA is intending to upgrade Africa RCC to be accredited or designated as WMO RCC compliance, and then contributing in the sustainable development and climate resilient society in Africa. I thank you for this introductory lecture on ClimSA, and I will wait for any question during the interactive session. Thank you so much for listening and giving me your time.